And welcome everyone, the first meetup of Go in Los Angeles. Let's see how it goes with this experiment. It's my first meetup, and thank you to Mickey. We managed to create the first one. Let's see, the meetup, I want to create this meetup because I think sharing knowledge and actually doing things together is the way to learn how to program in a language. And besides just someone projecting some slide with code and try to follow along, I think programming is in a way you have to do it on site and actually experiment with it. And I decided to do from all the language for Go is because I think Go is gonna have has those properties that I saw in Python 7-8 years ago. So I think in 4 or 5 years Go is gonna go mainstream, and I want to foster the community to be able to get there and like be able to be prepared when that hits. So we're gonna start. The first one is gonna be about Google AppEngine. So as you know, Google created and sponsored the Go language, and of course they are the first to provide like a framework to use, and it's a pretty cool framework to start using and start learning how the Go paradigm should be used. So there are. I encourage some of the code is. I think all the code is open source of Google.
Yes.
Google AppEngine also, right? It has.
The Go library, I don't know.
I saw some of them are pretty. So it's a good read also to go through them. One favor I ask, like this is my first time to promote a meetup, right? Like it's from an engineer I never promoted. Please share. As much as you can to the public that this meetup exists, because I found it is very hard to spread the word about something so simple. Like I started to respect more marketing people that I have to push an idea out there. Is like with all the data that's out there, it's very, very hard.
I started with a little bit of overview. Anyone has an experience with AppEngine? One. Okay, so the idea is that it's all fun and games until you have a scaling issue, and then you really need to do something. And AppEngine main premise is that they'll give you Google Scale. So you write your application inside their infrastructure, and they will give you the scaling that you need. Of course, you pay money for that. So there's a downside also. So the stuff you get is Google-sized scaling. You get deploys without downtime. You get versioning of your application, so you can deploy one version and play with it with A/B testing and things like that. You get a data store, which is a distributed database, which has its own query language called JQL. You get user management, memcached, logging, admin console, and a lot of other things. Things that you lose is the freedom to do whatever you want. So it's very much sandbox, and you can use, depending on the framework, only the things that Google approve. In the Go world, it's only pure Go packages that come within, and you can't do writing to file system and things like that. And arguably, it might cost you more money than running your own services on a micro instance in Amazon or something like that. I'm saying arguably because development time is also something you need to factor in. So I don't have experience with big applications there. I wrote some toy ones and one that was used by my kids' school, which is not a lot of scale. So let's go to so when you go to the AppEngine SDK, you create an application. So this is the application that we're going to do. It's called Go Shorty. Automatically, it gets it's hosted under appspot.com. So goshorty.appspot.com is your application. You can hook your DNS and have your own domain there, and have the top-level domains and things like that. There's some issues with SSL and certificates. I think they're on the way to solve that. So one of the things off the bat is the nice dashboard that you get. So you see how many requests, how many things you have, see how many instances you're running for this one. So I'm running this on the free tier. So currently there's almost nothing running. You get a unified logging, which you see all the application logs with things that happen, all kinds of requests. You can filter them out. You can look at them. You can see versions of your application. I'm just deploying one version, but if you have multiple versions of the application, you can see them as well. If you have backends are things that run in the backend and can perform continuous tasks. The AppEngine itself is very oriented towards being a web service. So almost everything is structured as a web call to something, but sometimes you need the longer running things, and that's where you get it. You have cron jobs, so you can schedule stuff with cron, task queues to run tasks, and then you can go over the data. You can see what indexes they have on the data. You can actually view the stuff that you have there. We'll go after that later, but you can actually see the entities, you can delete them, you can view them. And another like blacklisting and application settings and things like that. So right off the bat, this is really nice to have in an application. If you create it from mix and match of other things, it's usually harder to find. So the application we're going to write is a URL shortener. It's just like Bitly. You enter a URL. Step one. This is not a long URL. Let's take a longer one. And once you give it the URL and you shorten it, you get a new short URL, which is D in this case. And if you hit the D one, you get redirected to where you go. And you also see if you're logged in as a user, you see your own URLs and how many times they were hit. And all this we're going to develop. Excuse my UI, it's horrible, and I know that. So
Mickey,
yeah,
the Google AppEngine will handle all the auto scaling, auto resource for you. You can just
yes. It also gives you local caching, memcached, and things like that. But if you want to talk between your applications, the data store, but there's some other ways to do it. Okay, so to get started, you download the SDK, you drop it somewhere, and it's basically a bunch of Python files. So you need Python to run the AppEngine. It installs its own Go compiler, which currently I think it's a version 1.01 or something like that. And that's it. So let's dive into the code. So the way it's structured is there's 1, 2, 3, 4, 5, 6, 7 until 9. We're going in steps. So we'll go for every application. The first one is very basic, just showing some capabilities. We'll see that you can run it actually and have it up and running, and we'll go from there.
Everyone has the project downloaded. What you said?
Okay, so the first thing you write is basically the definition file of your application. It's called apple.yaml. It's in a YAML format. YAML, if you don't know, is a serialization format. So application, this is the application ID. This is the one that is .appspot.com, sorry. The version, and again, you can increase the version of your application and then do some mix and matching with versioning or do some A/B testing and things like that. You say that the runtime Go, so you want the Go runtime. AppEngine supports also Python and Java runtimes. And then in the handlers section, which tells the AppEngine how to redirect your traffic, you say that I want everything to go to my my Go application. So _go_app. This is just a board. You just copy it, and this tells the Go to run. So I'm calling this package shorty. So it's inside the shorty directory. And there is just one Go file. Notice that there's no main here. So the AppEngine itself will call main. If you will run this as a standalone application, you just need to add a main with HTTP listen and serve, and it will do the same thing. And in the init, so at line 9, so init is a function that in Go is called every time a model initializes. It's something like a constructor for the model. So we're saying to the HTTP that we're handling this path with the root handler, and the root handler will just print hello AppEngine as a reply. Questions about this code? Okay, if you're new to Go, this is somewhat C syntax with a few extensions.
Do you always have to define the init?
No. So init is, if you want something to happen when the model is initialized or when it's imported, then you place it as an init. The same package, if there are several files, they can each file can define its own init and they'll all be called.
The name of the folder is important, right?
Yes. Yeah. So it's the name of the package itself. So you define the name of the package, do a couple of imports.
Sounds like a module.
Yes, it's a model. That's, so running it. So running it is, this is running it locally. So you call the dev app server, dot, which is the directory that is currently here, and you can pass it to other parameters. There are several parameters. So if you run the help, you can see that there are a lot of parameters you can pass it. It actually gives you a full simulation of the environment, including development console and data store. So you can nuke the data store, you can define different port, you can do a lot of other stuff. I won't go on that. We just run it locally, and notice the thing that says that there is a admin console available here. Okay, so first let's go to localhost 8080, and we see hello AppEngine.
One trick about the semicolon is that the parser will add a semicolon at the end of all of your lines. Okay, so it's basically is needed by the parser, but it's not needed that you put them in. But it will add a semicolon at the end of the line.
Yes. So one nice thing about this development environment is if I'm making a change to the file, I can just hit refresh and it will compile and rerun the application itself. So it's nice when you do local development. You don't need to restart the server every time. You can do local changes in your code and it will pick it up and do it. Now, one nice thing about Go, it compiles really, really fast. So you can do tricks like that.
Is it going to compile it on the next request? Or should I see
only if it changes. So it knows if something changed, and if it will change, then it will do it. The other thing is that in the local development environment, you get also a smaller version of the admin console. So again, you can watch the data store, you can see if you have stuff inside the data. You can look if there's stuff inside Memcache. You can see the task queue, cron jobs, XMPP. So AppEngine gives you that. So if you want XMPP support for your application, where users are aiming each other, you can do that. So it's supposed to be a subset of what's there on the admin console. But again, when you're developing and you want to watch your data and see what's going on in there and see stuff, it's really, really helpful.
I get the stack trace on it.
Yes. Let's move to the next step.
Just change
Any questions about this step?
Server.py. Change the shebang line to say just 2.7 instead of 2.5. It works.
Is the hash bang?
Let me show you before that how do we push to AppEngine. So line 7 is you do cfg update this directory and it will push it up to AppEngine. It will deploy it. What I usually do in my push script, I also tag this is the version that went to AppEngine, so I know that this is where it goes. I'm using Mercurial, Git, or everything else should work as well. So that's the push script that I
Hey.
Okay, so for the second step, what we're going to do is we're going to use template. Go comes with its own templating language, which binds well with the HTTP package. It's
Did you register before?
maybe a bit more restrictive than other templating language if you used it from Ruby and Python, but it's good enough for most of the stuff I see. Notice the first thing we do in our app.yaml is that we actually add another handler. So we used to have just the handler for going to the AppEngine, but now we're saying that everything under the static directory. So if user hits -static, Google will do it's a static file, and they can do a lot of stuff with CDNs and things like that to distribute these files and save it for you. So they serve it directly. Your application doesn't need to worry about that. This is the first thing. And in static there, I have the logo and I have a CSS file. Just for writing HTML files, you can write the files in .html and it can get uploaded to the AppEngine, and you can serve the file itself on the content. What I'm doing here is something a bit different. I'm embedding the HTML in a Go file, so I have the HTML already ready as a variable that I can. It's not a variable; it's a constant. So I'm defining an HTML. Nothing really interesting. Notice just the two references, line 7 and 8, to the static. So these things are going to be hit by the AppEngine, and then I'm having a header, the form itself, and the footer class.
Miki, that's the backslash is for having multi-line
Yes, it's
strings.
Yes, yeah. You can embed it's raw strings, I think called. I'm not sure exactly. And in our code now, we want to use this template. So we're importing HTML template now, and we're losing the font package that we used before. So in Go, every import that is not used is an error. It's a compilation error. You can't import just stuff. It annoys the hell of a lot of people, but that's how it is. The developer made it really clear that that's the way it's going to stay, and that's it. So there's some ways to mark imports that telling the compiler to ignore them, but basically, if you don't use an import, just remove it. So we're defining on line 9 a template, which is we're going to use it. And in line 12 in the init, again, we load it from this home HTML, which is the constant we defined before. And template.must is something that will either parse the template or will do the equivalent of exception, which is called a panic. Are you good now? Okay. Oh no, you didn't have a problem. Okay, so we just compile it, and in line 18, in the root handler, we just execute the template. And we pass it nil. Nil is an optional parameter that you can pass to templates to be expanded later, and we'll see how it goes. Okay, and let's run this one. Okay, now we have the form, we have the ugly CSS that I wrote, and everything. Okay, and even the and notice that we had a get for the static files, and we got it. We're okay. Questions so far? Okay. Good day. Okay, so now let's move on. Next step, we're going to start using the AppEngine infrastructure and adding user to the mix. So this everything there is in the 3 directory. So there's no changes to app.yaml or to static or anything else. The only thing is that there's some changes to the shorty code itself. Stefan, do you need any help setting up?
No thanks.
You good? Okay. So notice now I'm importing AppEngine and AppEngine user. And in Go, when you import AppEngine user, the function will be just the last part of it. So user.something. And now, I'll show you something has changed. So these are the parameters that are going to be passed to the template. So the template is going to expand them. So I'm calling it home params, which is a really bad name. But there is a user, a login title, a login URL, and then if there was an error, everything there is a string. So if you look here now, this is in line 14, this is a way that we access these attributes. So we do double curly braces and dot something, and this will actually get the attribute of login URL from the struct that is passed, and we'll fill it inside the template. And again, this is an if statement, so if there was an error, if there was an error in the, if you filled in the error, filled in the structure, then we create a new div. What happened after the line, the HTML after the pipeline, meaning I want it to be formatted as HTML safe. So if there's some HTML code inside it, it will escape it and make it safe for presenting as HTML. You can write your own formatters, and if we have time, we'll get to it in the last step.
Mickey, one thing I want to add, mind the case of the property.
Yes.
It has to be uppercase.
Yes. So in Go, there's no private or public. The convention is everything that starts with an uppercase is public and exposed to the other packages, and everything that is lowercase is not exposed.
And it's not just convention, it's enforced.
Yes, it's how it works. Yes, yeah, you're right. It's more than a convention. It's how it works, and it's something that really bites you, especially for me when I started parsing JSON, and I started fields with the lowercase because they were lowercase in JSON, and nothing comes out. And so now that everything that you want exposed should be uppercase. And here we just greet the current user. Okay, so let's start with the root handler. Two things I wanted to notice. One is that you get a context. So you get something which is called an AppEngine context, and this is the stuff that you pass to most of the calls to the AppEngine API. So we create a context from the request itself, and this one is going to be passed around every time. Second thing that I'm using here, so Go has something which is called a defer. And defer means run this function when the enclosing function exits. The equivalent, if you wrote a C++ code, is you put an object which has some code in the destructor, so you know when the stack's unwind, this destructor is getting called. It's used a lot for locks, so you don't forget. So I'm using it here for actually doing the filling of the parameters and doing the final emitting of data. So I have just one execute calling. And so I'm deferring an anonymous function which check if there was some error. I'm filling the error variable, and I'm logging the error as well. So this one will log it, and this error will be viewable on the admin console. So I can go into the admin console and have a look at this error. And then I'm executing the home template with the parameters. And currently what I'm doing is just filling the user.
Why are you doing it at the defer?
I'm doing it defer because later on when I have more cases and when I have errors, I don't need to remember always to emit something outside. Just when I exit the function, this defer will do that. And I can exit whenever I want. There's still code always execute, catches what's going on, and emits it outside. It's nice. You don't have to do that. You can do it at every exit point. But I found it really helps me not forget to. There's an error, nothing comes out.
Does that happen only on on the proper flow of execution, or does it also have
On
to
any
be like
flow.
an exception?
So Go has something like exception, which is called pawning, and but it happens in both cases. They're highly discouraged. Go mostly works with error values, so you can return multiple values, and most of the function what they do is they return a value and an error value, and you check the error value. If it's good or not, then you do that. So filling the user. So I'm passing the parameters, the request and the context, and I'm asking who's the current user, and if it's no user, then the login title will be if there is a user, sorry, then the title will be logout, and there's a logout URL, which is a URL that Google gave you, which you click on it, it logs you out from the system, clears the cookie and everything else. And then if there's no current user, it will give you a login title and a login URL, and you can go there.
Interesting. So I guess that abstraction handles, token auth as far as your Google account, things like that?
Token what?
The OAuth callback and things like that, that's what's going on with.
Yeah, so they have their own user management, but you can say that this application is using a different authentication or user management. They support OAuth 2 and some other ones, I don't know. I don't know. They have an API for it. So I'm logged out. So if I'm logged out, I'm currently no user, so it will be login, and you see the URL down there is going somewhere to the admin console. And once I log in, it gives me a dummy user. And I'm logging in, and now it's known that I'm logged in. It says good day and gives me the name, and the link here changed to logout. So I'm filling the user details in the parameters, then passing them on to the template to execute, and executing the template. Questions?
The logging page is AppEngine internal?
What?
The logging page?
Yes,
shows-
yes. So if I go to the real application, which is on AppEngine, and I log out, it will log me actually from my Google account. And when I log in, see, it gives you your actual Google account. And,
They really made that easy to integrate into your
yes.
app.
Now I need to remember my Google password. Yes. Oh, wow. Never. So yeah, they make it really easy to integrate it. It's a nice thing. It's one less thing that you need to not forget. Of course, it requires your user to have a Google or Google Apps account, and if you want to handle your own users, there's some ways you can do it. Okay, next up is we're going to implement a counter. So we're going to data store, and we're going to have a counter because we want to have a running counter. Whenever we get a new URL, we want to increase the counter and use this counter as the new reference URL. So we're importing also on line 9 the data store, which is the AppEngine for data store. And I'm defining in line 14 to 15 the key name and the key kind. So whenever you store an entity in the database, it has some kind of a type, a kind. And every entity has a unique key name. So you can, when you save an entity to the database, you can tell the database, give me your own unique ID. Or you can say, this is the ID I want to use, and just one. Okay, and the counter itself is a very simple structure. It just have the count. Again, uppercase. Okay, this needs to go down, so only things that are uppercase actually get saved. And it's an int64 integer. So this is the function how we get the URL count. So how many URLs we have so far. So I'm passing in the context from the AppEngine, which we created with the main. And again, it's pretty straightforward. The 81, I'm getting a key. I'm creating a new counter, which is new is a Go keyword for creating a new structure. So I'm creating a new structure. I'm doing a get with the database with this key and this context and this pointer to this structure. And if it's the first time, then on line 84 I'm returning 0. And other than that, I'm returning count. Okay. Sorry. So here I'm checking if there was an error, and the error is not no such entity. So there was some other error accessing the database for some reason. I'm returning this error. And you see, this is the idiom that I told you about a function returning a return value and also an error value. So I'm returning a value and an error value. So now, if the error was that there's no such entities, it's the first one, it's still fine because Google initialized every variable to its default value. So counter.count will be 0, which is okay, and then we'll return it. And then what I'm doing here is in 958 in the main function, the main handler is I'm setting params.count and error to URL count, which means now that I will have the right count, or in case of an error, the error variable will be set up, and then the defer function will find out and fill the error. Okay, and it says here, no, this is the wrong one, this is the AppEngine one. Okay, we added the line, good day, and we shortened 2 URLs so far. We have 2 URLs because
Same data storage.
I did before, but I think C is the one that tells you to nuke the database. Yeah, and this is, now it says 0 URL so far. So it didn't find anything in the database. And go. And then at the HTML, we just add this to the template. We shorten .count URLs, and we have this line at the bottom. Questions so far? Am I boring you really well?
Is everything clear?
Okay, so let's start shortening URLs. So for making short URLs, we'll do something which is called base 62 encoding, which means using all the lowercase and uppercase English alphabet plus 0 to 9 as the base for numbers. So really big numbers are encoded in a really short way. I won't go over the code of how to do base 64 encoding, base 62 encoding. You can have a look at that.
Is there a reason why base 62 is preferred over base 64 in this context?
Base 62, it's just if you take the number of lowercase plus uppercase letters plus 0 to 9, that comes to 62. So that's why.
Okay.
Base 64, what's the other two? I don't know.
Plus and slash?
Slash and plus, and then there's an alternate that's dash and underscore for...
Slash is problematic for URL identifiers.
There's an alternate
Well,
that uses dash
you
and
can-
underscore.
You can just make your own in the base 64 library.
Oh, okay.
You can just
Okay.
name your own alphabet.
All right. So, new to me, I could have used that. Yes. Thank you. So now there's URLs that we're going to store in the database. So we're going to store the short URL, the long URL, the user that created this URL. When it was created, and this is time.time, so Go has a time type, and how many hits this URL had. So every time we actually click on the short URL, we increase this hit count. So we can do that. Okay, so this is a little bit of code. So, if the method is a post, it means that we got something from the form, and we're looking for that. So the way to get it is from ours, the request object that was passed to us by the HTTP package. See the request object. So it has a form value, which you could get values from HTML forms. So I'm getting the URL aspect of that. And I'm checking if it's not a valid, then I'm saying the error is bad URL. And valid URL, there's some definition there, I don't remember what I did, but just checking. And then I do return again. This is where the defer comes to play. I fill the error, I just return, and defer will take care of that. If there's no schema on the URL, I'm adding HTTP colon just to make sure that it's there.
Just wanted to point out, they do have a predefined base64.url encoding.
Oh,
That's,
awesome.
it
That would have
uses
saved some
dash
time.
and
Yes.
underscore, yes.
Yes. Okay.
Exercise for home.
Yeah. Well, it's good to know. So if there's no schema, I'm adding a schema, and then I'm getting the ID. It's called new short URL. We'll see it in a minute. And then I'm adding that to the params, the short URL, because something which is called the full URL, and I'll go on that in a minute also. So I'm having a URL count, which is basically the one we saw before that returns the value of the current counter. So I have a global counter. Every time someone creates a new URL, I'm incrementing this counter by 1 using this value encoded as base62 as a short URL. So this is the one that gets me the next ID. What I'm doing, and this is nice because line 132, this is running into one transaction. So in one transaction, I'm getting the value, incrementing by 1 and saving, because I don't want 2 instances getting the same thing. So one transaction gets a context and a function to run it. So I'm defining a function that, again, does the whole thing of get a new key, get the counter, get the current count, increment the counter, put it back in, and have the count back. And then I'm returning basics to encode the count itself. So the whole thing runs in a transaction, getting the global counter, incrementing by 1, saving it. I'm out of the transaction, then I have the current ID, and I'm converting it to base62. The full URL is just to make it work both locally and on AppEngine. So I'm getting the host name from the request object. Because an AppEngine it's need to go to goshorty.apps.com, and here it should go to localhost. So I'm just getting this one. And a new short URL is exactly does that. It gets it gets the next ID, creates a URL object, stores it in the database, and returns. Okay, so the way things are, you get the stuff from the form, you get a new ID, create a URL, save it to the database, and return it, and in the template now, we add URL shorten to this short URL. So let's take this URL again. Okay, so URL shortened to this one. This is B. And if we refresh, we see that it says that so far we refreshed. We had one shorted so far 1 URL. I had some bug there that I get the global data only after the transaction.
If we just hit refresh, it keeps counting the number of URLs.
Yes, because every time you hit refresh, you do another post.
Okay.
So
Even though we don't have any.
yeah, it's not
URL.
checking if it's a fresh URL or you don't have it or. No, I'm not doing these checks. I'm just storing it. That will fix the bug. Okay. So this is this step of getting data, storing it in database, and showing it out. Questions about that?
Can you go back to the transaction code? And I think that's the trickiest part on the whole thing.
This one. Yeah.
You guys notice there is like a anonymous function inside.
Mm-hmm.
Yeah. This one is defined here.
That is one of the nice things of
And
Go that wasn't there in C, right? Like you can create an anonymous function and use any variable of the external context inside the internal const.
And that ends at line 146? That
It
function?
ends.
147.
Yes.
A closure.
Mm-hmm.
Yes. Yes, it's a closure.
And you can pass them around like uncreate and have functional return function, all the nice things that were used.
Is the second argument there that's currently a nil, is that something that would be executed if the transaction needs to be rolled back?
Which one?
In line 146 there, where that nil
Oh,
is for the second argument, is that a second function?
Run transaction.
That-
That's the third argument. Is for the
Okay.
run transaction.
Mickey, how
Yeah,
would
I know it's the third argument to it, my question
Oh,
is,
what's
like, how do I roll back the transaction?
I
or,
don't know.
or Mickey, how would you find documentation about this particular function?
So
My guess is that if you returned an error from that function, it would roll it back.
Could be, right?
I don't actually know the AppEngine API, but that's how I make it.
So this is the documentation, and here we're using transactions.
Oh, nice.
I don't see what's the value of
If the function
Yeah, I
returns
see it there.
nil, it attempts to commit. If not,
If it returns a non-nil error value, any data store changes are not applied.
that. Yes. Well, that's the closure function.
so it's a rollback.
Uh-huh.
Yeah, but you asked about this now. And
Yeah,
don't-
I was thinking that it might be,
Ah.
maybe a function that you execute
Oh.
as part of the
I
rollback.
don't. No. So yeah. So this function, you see, I'm returning error, which should be yeah.
That second paragraph there is kind of interesting, the fact that it'll try again.
Giving up after 3 attempts.
Yeah.
Yes. Because it's distributed. And things like that, basically, if you don't know, it can cost you a lot of money, because if you do 3 transactions every time instead of one that you think of, your bill can be more interesting. So this is one thing. There's also, what was it? So this is the reference section.
Mm-hmm.
It talks about entities, properties. And there's running transaction.
I see.
Uh,
Oh,
and
options.
so some kind of transaction options that you can pass around.
Okay.
I don't know exactly what.
Sure.
Yeah, more.
How did you get to that page? What is
Oh, this one is
it?
the
Data store reference. Okay.
yeah. So yeah. So if you hit the reference on every section, they have a reference. So I think it would be that. Yeah, they have a reference for everything. So if you're on the channel API, there's a reference, and the reference is showing. I think it's the output of Go.technology.
Mickey, can I do a quick recap of where we are?
Yes.
So we are at step 5, right?
Yes.
So in the first step, we create the basic page to display a simple hello world. Then this second step, we added a simple template, and until that point, we just using basic Go
Yes.
SDK, like no need for AppEngine. When we need the user login and authentication, then we start using the AppEngine SDK and use the AppEngine user library.
Yes.
Then we went to step 4, that was to be able to increment a value and persist it each time we store a new URL. And then in step 5, we took this URL and we convert to a short version using a handmade basics issue.
Yes.
encoding.
I know better now.
But that's the thing, we are here to learn, everyone. We're not here to teach, we're here just to share what we did with our home project. And if anyone knows another way or something more fancy or interesting, just share.
Yes.
Is the AppEngine data store, like, is a memcache, or is that?
You can have memcache. It's a different system. You can have memcache. Memcache is not persistent. So if you want for fast, and I'll show you an example here. So you have memcache there, but it's not. It's another distributed database which is provided to Google.
It's behind a curtain in a black box. you
Yes.
Something like Redis or like.
So
Yeah.
you just know
Big
use data
database.
store.
And-
Yeah.
And there is no trusting it whatsoever. The AppEngine one. I mean, you shouldn't ever trust it, but on your own box, you can trust it a little bit more.
Well, they
Yeah.
have your email, right? You have a Gmail account, so it's the same thing, like more or less. Right? You will not run your own email server, right?
As I said, my experience with it is in small scale, really small scale things. But I think for someone who just wants to start and has an idea to go
Yeah.
from zero to application there, it's super simple and it's easy.
Step 6.
Step 6 comes after 5. In 6, we're going to do redirects. So now, we're looking at the root handler again. So now, if the path is not just a straight top level, we assume that it's a short link. So we're going to handle it differently. We're calling the redirect handler and returning. Otherwise, we continue with the same path that we were before. We assume that everything that has something after that is a redirect handler. So the redirect handler is pretty straightforward. Go to the data store, by the key of the short URL, grab an object from there, get the long URL, increment the count of the hits for this URL, and redirect. Okay, so we're doing the get URL, which we already defined, and if we don't find anything, we do a 208 return an HTTP not found, and and then we increment the hits and we do the redirect. Okay, I'm doing with temporary redirect. So next time when the browser will come, it will go first to my page and will not bypass everything. And increment hits, again we do it in the transaction. We get the URL, we increment the hits in line 38, we save it again. We're done. Okay, it's pretty straightforward. Okay, and the URL key, which is the key for that, is returning a new key from the data store with the short URL as there. So we get a new key object, and this is the key we use for querying the actual URL. There's some more fancy stuff that you can do with keys and objects, that you can define some kind of hierarchy between objects and query on the hierarchy, like parent and child and things like that. I'm not that familiar with that, but I know it's a possibility. Questions about that?
Keys can have parents and child? Or?
I think you can say I want a child key of this parent key and store an entity, and then say this parent key I want all the children, and there's a query for that, things like that.
Might be very similar to DynamoDB, where you have a primary key and a secondary key to query. You want to query the tuple, no, where the primary key is this and the secondary key is something like that. I'm assuming. I didn't read the actual specification.
Okay, so this far we shortened this URL, we got this one, and now if we hit localhost-c, it will redirect us to the original page that we came in. And that's it. So far we have most of the application. The last part of showing the user URLs is at the very end if we have time. Now we're going to do a couple of optimization to make it fast. And the assumption I want to make is that I want to make the redirect handler faster. And my problem is that the redirect handler needs to touch the database every time. So it touches the database to get the URL, but also touches the database to store again the results. And I need to know. So I would like to make it faster. So first one is we're going to use memcache. So on 9.14, sorry, we're using memcache. So AppEngine gives you a memcache API, which you can query. It's faster, it's in memory, but there's an expiration date on what's going in there. So sometimes the stuff can be there, sometimes it can be not be there. And in the redirect handler, we first try to do the memcache get. So we have the path, which is the key we're trying to see. And if we didn't get it, then we go and do the code from before to get the URL, and we store it in memcache, which we do in line 217. Okay, we say memcache item, this is the key, this is the value. And notice that the value needs to be a byte array. So we convert the string, the long URL string, to a byte array. And then we set it in. Okay, otherwise we found it in memcache, we just get the long URL, then we continue, we increment the hits and do the redirect. So we got rid of one access to the data store, which is just finding the URL. First time we will have a cache miss, we'll go to the database. Second time, hopefully, if it's popular, it will be in memory, and then we just do a memcache.
Another good reason to have and use a memcache is the data store has threshold, like how many times you can hit the database. So you want to have that threshold far away from
and
it.
I think until recently, memcache was free, was not in the quota. Am I right?
It still is free, isn't it?
Yeah.
No,
it
they
is.
don't count it on the quota, right?
Yeah.
It doesn't get counted on the quota, but your database reason rights do.
Yes. So it also says in memory if you store more stuff on memcache, because a lot of memory, money. Saves you money because there's less to the database. Okay, so
Money
the
is
second
better
thing.
than memory.
What?
Money is better than memory. I'd rather save that.
Yes. Well, I've lived without the memory for a long time. So. The second thing we're going to do is we're going to update the hit count on the URL not inside the HTTP handler. So AppEngine supports something which is called task or task queues, which meaning you say, I want to do this later. So it's scheduled, behind the scene what happens is schedule this call to later. It hits a URL that you specify, and then it's going to get called, but it's not part of your current request handler. So it's just delayed for later. There is a way to do it. What?
Why not just do it after redirecting them?
What?
Can't you just do it after redirecting them? Increment the counter after sending the redirect.
I don't know if the handler closes the code. So if you do template.execute and then you have more code, will it release the connection?
Sure.
Okay. So that's one way to do it. I wasn't aware. I thought it was keeping the connection until the function exits. So every time you have a handler on a, which is called.
Oh, no. Oh, wait a minute. What do you mean?
So I want to do the redirect and be done with it and do the increment later. I don't want to do the increment inside the redirect.
So all you have to do is wait until after the redirect, right?
How can I wait after the redirect? After the call to redirect?
Yeah. Just put the.
So
function
I
called
wasn't clear
redirect.
on that. So you're probably right.
Where can I get this code, by the way?
It's if you go to the meetup page, in one of the comments, it's there.
So
I mean, I don't know AppEngine well, so.
Okay.
but basically, when the client hits the server, we have a handler that's registered with one of the URL. That handler is a function, and when the function completes, then the clients receive the response. What we are doing now is we receive the handler receive the request, we create a template, we increment the counter, and then we respond to the client.
You can't close the connection before, before returning?
You could do that, but it's at a deeper level inside the whole application server. What we want is we serve the response to the client, and we put inside a queue or say, do this operation when you have time. Okay, so the count operation that could be expensive is being done asynchronous, so your client is much faster.
And also it served my purpose of displaying this API.
Nice. Where? Is it this? Bitbucket? Okay.
Yes. Yeah.
Then go to downloads. Somewhere in here.
Okay.
Go meet up?
Yes.
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 Go in the downloads.
Yes. In the downloads you can download the tip, or if you have Mercurial you can just clone whatever you want.
So we're in step 8.
Yeah, so step 8 is actually using delay. So the mechanism that works, as Fabrizio said, that you said to AppEngine, I want to execute this later when we have time. This is the URL and this is the parameters you're going to hit it with, and you provide this parameter. The AppEngine Go SDK provide a shorter way to do that, which is called the delay function. And what you basically do is write in English. So use the AppEngine delay. See here, this is another import we're doing. And we said this is the variable delay. I give it a name, and this is the function I want you to call when you call it. And the function is inklets. And inklets is a function that should have this signature. It gets a context and a parameter, and it's actually doing the whole work. But now in my my redirect handler, I'm doing this one. I'm doing this thing. So I'm calling it delayed fashion. So now it will be placed in a queue. We can continue on to doing the actual redirect code, and later on, when AppEngine has time, it will happen. What it will cause is that when you look at the hit count for URL, it will take some time to update. They want to be updated automatically, so whenever you look at the hit count, it will take some more time, which is okay. So there might be a slight delay. It depends on the task queue. I don't remember exactly how AppEngine schedules tasks, but I think there's some effect on global load, right? So if there's global load on tasks versus, it might happen that your task will actually happen in a few minutes or even a few hours.
But it's at least,
yes.
First in, first out.
As part of your concerning, I
Right.
think so. I'm not sure if there's going to be an order.
No, I would not guarantee that.
No?
No.
Okay.
Because if you want to scale that, you most likely you will use more than one queue, right? And have the one done queue with the same name of the queue and have multiple server fetching from the different queue. It's better to not guarantee. SQS on Amazon doesn't guarantee it. Let's say that.
But the idea is that if you have something which is taking a lot of time and you want your application to be more snappy, you can delay some computation to later. And again, behind the scene, what it does, it generates another handler, another ATP handler, another function, and creates that and calls that. Questions about that? Okay, so delaying. All right, we got to the last part. Let me consult on memory. So first, let's look at the HTML. I'm going to do some changes here. So I'm going to show a table below which shows all the URLs that a given user has shortened and what was the hit count for every one of them. So note that now I'm using some kind of template magic. So I'm doing range, which means basically a for loop, an iterator on all the things that are passed in. And doing it with the URL. So the parameters now is going to get a URLs field, and this field will be a list of URL structures. So I'm doing with that, meaning this one is going to be the top object now, and then I'm iterating. I'm using odd even, which is, I'll show it shortly. It's something I write. So this is a formatter that I wrote for showing odd and even lines, the stripe lines in the table. I'm showing that. I'm showing the long URL. I'm showing when it was created, and again, this is a formatter for the time. So dot created, if you remember, was a time.time type. I think it's just an integer, and the number of hits, and then that's it. So I'm going to do a table.
What's the single period on line 39?
This is the current object. So when you do range, so it does range, and then dot will be the current item that you're looping over. So if you have a list of 1 to 5, dot will be first 1, then 2, then 3, then 4, then 5. But the range gives you the index and the object itself.
Mm-hmm.
If you know Python and enumerate, same thing.
So what exactly is URL in that?
So
It's a
if you look at,
complex object, right?
so
Oh, is that like key
URL
value?
is this structure. It's a structure of a URL. So URLs is an array of these. So every time you get a reference to one of these objects, and
What's the object that we pass to the template?
yes. So if you look at parameters now, there's a URLs, which is a pointer. It's an array of URL pointers. And if you're used to C, Go is always switching where the type is, which gets used to. Instead of string user, it's user string. There's a discussion there why it's better, but I won't go into that. So these are the formatters. I created a time formatter and an odd even formatter. So all the formatters has the same signature. They get some kind of argument, and I'm getting this is Go's way of casting. You switch it, you cast it to a type, and you get an okay if the casting was successful or not. If it's not okay, then you return an error. Otherwise, you do a format. And Go also went away from this sprintf format that we're used to from C, and uses a human-readable format. So this is not the actual string, but this is the fields in the string. So this is a year, the month, the day, and the hour. Okay, and the same thing for odd and even. So if it's an even line number or an odd line number, I'm doing that. So I'm declaring a function map, and then when I'm passing it to the template, I'm also adding .fax to this function map. So now the template can use all these formatting. That's one thing. And then I have a function is a user URLs, and here I'm using the query language that Google gives us. So I'm having a user and the context. So I'm saying I want a new query where you filter where the user equal to the current user, and I wanted the order minus created, meaning I wanted descending order by creation, and I want the maximum of 1001. 1001s, and then I'm running the query, and then I'm getting there. Now, a word about this thing will require an index. So the nice thing about so if you look here now at 9, when you run it the first time, there's a new file. It's called index.yaml. And this is generated automatically by the developer engine when it sees the queries you're running. It says, I think these are the indexes that you need on your database. And when you update it, it will go and create the indexes. And if you look at it, see, this is auto-generated. You can also do some manual tweaking if I'm not. So the kind of object that we're indexing is the URL. The properties that we like to index is the user and created. And the created we like it indexed in descending order. This all comes from the query that we run. And when we're going to upload the new version to AppEngine, it's going to index the database. Now, indexing is going in one queue for the whole AppEngine, or something like that. So it can take a lot of time sometimes. I had indexing going on for small databases, but it took about 2 days until it actually got to run the index. So when you're doing that, you need to be really defensive on your coding, making sure that maybe there's no index sometimes, and you should code for that. So there's a fix me here. It says handle no index errors. So sometimes there's no index built right now, and you need to be aware of that in your code. So one way that I can think that you can do that is actually deploy your code, but in a new version, but still make the old version the active one. And only when the indexing is done and the AppEngine API, the console tells you that it's done, then you can make the new version that relies on this index, the default version, and then it will start using it. So you can do that. Or you can just upload the index and wait for the indexing to be done, and then go on with that. But beware that it can take a lot of time. So again, we make this query, we run it, and then we get an iterator, and then this is a while true loop in Go. We get the next item. If it's done, then it's done. Otherwise, we append it to the list of URLs until we get the whole URL. Okay, so now we have that. It knows that it's me. I have two URLs I created. I have the number of hits on every one of them. So if I go to C and refresh now, you see now I have 2 hits on C. Okay. So JQL is somewhat like SQL, slight differences. You create a new query like that by chaining. There is also an option to actually create the string of the JQL yourself and pass it around, if you want to do that. And that's it. And that's the last step. So we have a URL shortener with users, database, templating, and everything else. Questions? No.
Questions?
Yeah. Okay, so Go lines, it's about 250 lines. And the rest is CSS and things like that. 270 lines, if you count the redundant basics.
You have a pretty much scalable system that can be hidden by
Yes.
millions
Yes.
of users.
Yes. And as I said, the AppEngine gives you more stuff to play around with, XMPP, and other things that.
Does Google have documentation of the templating engine for Go?
So I found templating, there's documentation, the Go language site about templating. But I find it always confusing. It's always confusing to use templates. I found there are 2 sites that actually do it with examples, and these are the sites that I usually, when I go to, when I need to do some templating work, I go to them and use them. I can place the links in the
middle page.
Yes. Yeah. I can do that. One of them is networking with Go. I'll go and find out. But yeah, I don't know why I found the templating always confusing. Maybe it's a bit different from what I'm used to. There's other templating engines that you can use. There's a part of Mustache.
It's very similar to Mustache.
Yeah, but there's a full port to Mustache. There's some other templating systems. So you don't have to use one, but this one comes with Go. Another thing about, if you want to use external packages that Google does not provide, and you didn't write your own, but you want to use them, you have to have them locally next to your application, and they have to be pure Go application. They can't be C extensions.
This is in the name of safety.
Yes. Yes. Yes.
Their safety, not ours.
Well, if your application gets hacked because someone else wrote some clever code, then it's your safety as well. So,
If you're running the Go request handler not within an AppEngine instance, does it function the same way?
yes.
Okay.
Yeah. So if you go,
Well, this is the only code that they run on AppEngine that's native. So they needed to have something where they could test the safety of it.
The memory
Right.
safety.
Yeah.
Especially, yes.
yes.
The package is not made.
Yes. So if you don't know Go run, it's really helpful. What it does in the background, it compiles your application in some temporary files and run it. So it's not really an interpreter.
That's a very nice thing. Like it has.
Yeah. So that's the whole change I had to do. I added the main. For the telling HTTP to listen and serve on that, and that's it. It's the same application handler, same framework that you can use. So theoretically, if you build enough abstraction above users and databases, porting out shouldn't be that difficult.
Another one nice thing is the executable that Mickey has on his own laptop is the only thing you need. Like you copy that executable on
Yes.
another Linux machine, and it works.
Yes.
No
So
packages, no
Yeah.
dependencies, nothing of that. You have one executable.
yes. And that's one of the reasons I use the HTML inside the Go file, so it gets packed inside the executable. Otherwise, you need to ship also the HTML templates and things like that. The static directory, still a static directory, so you still need to ship it out, but everything else is there. And if you're interested, what is showing the auto-completion and function documentation, something called Go code, which is add-on that it's run as a server, and you can use it in Vim. I think also in Emacs, right?
Yes, I use it in Emacs. In Emacs and also Sublime.
Ah,
Sublime also has it. It's written in Go itself, so.
Yes, yes, and it's really nice. It does auto-completion. It does help. Yes.
I will add the
And
link
self-developer,
on the
yes.
meetup
Yeah,
page
this one.
too.
This one is really nice. So you get all the funds. That's it for me.
Okay, if anyone has other questions, speak now. Otherwise, I want to thank you, Mickey, for working with us, and I want to thank you also, AppEngine, for having us as a guest and sponsor this first meetup. The next meetup is going to be in a month. So this will run monthly, so we have time to prepare and have a nice hands-on session. I will try to get discount for books if anyone is interested, and also let's see if we can get some T-shirts and something that we can tag ourselves around, and the next Google conference. Please again share the tweet about it, picture, anything that you have that can support some of publicity. Common sharing, please do so. The emails, I will keep the emails at a minimum, and all the links, including free books or that are online, will be posted on a common page on the meetup, and also like the new link. Anyone that wants to share its own code is free to post on the board, and then even have a more direct. If someone wants to review some other's code, just post it on the review board. Will be maybe faster than or more direct than the Golang mailing list. If you are interested and you like what you see, subscribe to the Golang mailing list. It's growing very fast. Like I saw it in the last 4 months, going from 40 emails a day. It went up to 150 emails a day. So that's a good sign that people like what they see. And see you next time.
So as AppEngine, we're hiring if someone is interested in playing with a lot of data.
You're
Don't laugh. You know how much data it is.
I know how much data.
Yes.
contact Mickey.
Yeah, we're doing about more than 6 billion hits a month, and we need to handle all this data, and we're showing people.
Just getting more and more.
Should system manager go people? No.